everyone, and welcome. Today, we're going to dive deep into an unseen world, one that quietly powers our planet's oceans of lakes. We're walking through a practical, step-by-step guide to collecting and preserving plankton, those amazing microscopic organisms that are literally the foundation of all aquatic life. It's a great question, right? Plankton are the base of the entire aquatic food web, but here's the catch. Most of them are completely invisible to the naked eye. So how on earth do we study them? Well, the answer starts not in a lab, but out in the field, with the art and science of collection. So here's our roadmap. First up, we'll talk about how to actually catch these tiny organisms. Then we'll get into the specifics of the plankton toolkit you'll need for the job. After that, it's back to the lab to cover the absolute essentials for preserving your sample. And finally, we'll connect the dots and see how all this careful work leads to some seriously important science. Okay, first things first. Before you can even think about looking through a microscope, you have to be out on the water. The success of your entire study really hinges on this first absolutely crucial step, getting a good, clean sample. It's all about capturing a perfect representative snapshot of that invisible world. Now, if you want reliable scientific data, you can't just scoop up some water with a bucket and call it a day. Nope, you need specialized equipment. And choosing the right tool really depends on where you are and what you're trying to find out. What you pick is going to determine the whole story your data can tell. So let's break down your two main options for getting a really precise sample. On one hand, you've got the bottle sampler. This thing is perfect if you're working in a shallower spot, like an estuary. You just lower it to the exact depth you want, then send a little weight, it's called a messenger, down the rope, and snap, it shuts the lids and traps your water sample. On the other hand, if you need to pull water from a very specific depth, a pump and hose system is the way to go. It brings a continuous flow of water right up to you on the boat, which you can then filter to concentrate all those tiny plankton. All right, you've got your samples, you're back on shore, but your job is far from over. In fact, the clock is officially ticking. The next phase is absolutely critical. You have to preserve what you've collected, and you have to do it right, so the organisms don't break down before you get a chance to study them. So, what do we actually mean by preservation? Well, think of it like freezing your sample in time. By adding a special chemical, a fixative, you basically hit the pause button on all biological activity. This locks the organisms in a perfectly stable state, which means you can study them accurately weeks or even months later. Here we have our first recipe, and it's for one of the most common preservatives out there, Lugol's solution. It's an iodine-based fixative, and it's fantastic for phytoplankton because it does two things. It adds a bit of weight to the cells so they settle to the bottom for easier counting, and it stains them, making tiny features like flagella, those little whip-like tails, way easier to see. Now, a quick but important note on safety. Always handle iodine in a well-ventilated space, and make sure you're wearing gloves and safety glasses. And here's our second key recipe, preparing a formalin fixative. Formalin is a really powerful all-purpose preservative. The secret ingredient here is the borax. You add it to buffer the solution so it doesn't get too acidic and damage your delicate specimens. You let it settle, then carefully siphon off that clear liquid from the top, which is called the supernatant. Now, I have to stress this. Formalin is hazardous stuff. You absolutely must work in a fume hood and wear your personal protective equipment. I'm talking gloves, goggles, the whole deal. Safety first, always. Okay, so we've covered the how to collect, how to preserve, but that brings us to the most important question of all. So what? Why are we going through all this painstaking work in the field and in the lab? What's the real scientific payoff here? You know, this quote from the practical guide really nails it. Every single step we've just talked about, from sending that little messenger down the rope to carefully mixing your formalin, is done for one very clear reason: to prepare that sample for rigorous scientific study and identification. And this is the payoff. Those samples you so carefully prepared, they become incredibly valuable data points. Ecologists use them to map out entire food webs. They're essential for assessing biodiversity. They act as early warning systems for pollution, since plankton communities react so fast to changes in water quality. Heck, even climatologists use them to understand global carbon cycles. This isn't just a lab exercise. This is frontline science. So, the next time you're gearing up for a field practical, just remember, you're not just collecting a bottle of water, you're collecting data. You're capturing a snapshot of an entire invisible world. And with these techniques, you hold the key to unlocking its secrets. So the only question is, what will your next sample tell us about the health of our planet?